Unit 4, graphing trig functions. So now that we've learned about the unit circle and about all the special right triangles and SOHCAHTOA and all that, we need to learn how to graph, specifically the sine and the cosine functions. And so what I've got is the unit circle over here. I know some of you are still not used to using it, but we're going to use this to help us quickly graph what f of x or y equals sine of x looks like. So let's make a little table here of x and y values. Our x values in this problem are going to be our radians. Remember, radians are the numbers that have pi. And so first around the unit circle would be 0. And then let's do the next easy one would be pi over 2. So that's up at a 90 degree. Then let's go to pi, which is a 180. Then let's go to 3 pi over 2, which is 1.5 pi or 270. And then we'll end up at all the way around is 2 pi. Okay, so for sine, remember sine is the opposite from the reference angle, or it's the y value of the triangle. So at 0 here, the y value is 0. Up at pi over 2, the y value is 1. At pi, the y value is back to 0. At 3 pi over 2, the y value is -1. And all the way at 2 pi, we're back to 0. So let's plot those points. 0, 0, pi over 2 up 1, pi is back to 0, 3 pi over 2 is -1, and then 2 pi is back at 0. It makes this curvy function. That is called one period of the function. And so what happens is it repeats this pattern where the first point I would say is in the middle. We'll talk about midline here in the middle. So we'll put M for middle, then it goes high point, back to middle, low, back to middle. And you'll remember this pattern because we'll see it a lot coming up. Middle, high, middle, low, middle. Goes through the middle 3 times. But what I could keep doing is continuing that pattern, saying here's the middle. So then I would go high, back to middle. It would be low, middle would be another cycle or period. And then this way I could also go low, middle, high, middle, low, middle. But what I'm trying to get across to you is that this function does not stop. Ooh, my curves are not very good. But this function does not stop. Kind of reminds me of if you look at any kind of wavelength graphs in science or sound waves, that's what it reminds me of. Okay, so let's graph cosine. Let's make another little XY table. Okay, and we're going to use the same x values, our radians, all the way around the unit circle. So we'll have 0, pi over 2, pi, 3 pi over 2, and 2 pi. This time, though, since we're doing cosine, cosine is the adjacent leg of the triangle, or the x value. So here at 0, our x value is 1. And then our x value at pi over 2 is 0. At pi, our x value is -1. 3 pi over 2, it's 0. And at 2 pi, it's back to 1. And then let's graph that. So 0 up 1. Pi over 2 is to 0. Pi is to -1. 3 pi over 2 back to 0. 2 pi up to 1. Okay, don't make it a V shape. What it's doing is a curve like this. So that's the cosine graph. Its pattern starts at its high point, and then it comes down to its middle, to its low, back to middle, ends in high. So high, middle, low, middle, high. 2 middles versus sine was 3 middles. So I can continue this pattern of here's high, middle, low, and then it would be middle. And then this one, middle, low, middle, high, middle, low. It's kind of fun after a while. But again, it never stops. It keeps going. It's this wave-like pattern. Okay? You might notice too that sine and cosine are very similar. It's almost like if I took sine and I backed it up a little bit, it would become the cosine graph. The other thing that I always remember, cosine is called an even function because if I were to fold 1/2 over itself, it would be symmetrical. It's even because it can be reflected over the y-axis or folded. It's got symmetry. Over the y, where sine is odd, it goes to the origin, and so it does not have that same symmetry. Okay, but what the lesson is really about is finding the midline and the amplitude. The definition of the midline is the horizontal line that is equidistant from both the minimum and the maximum values of the function. It's the middle. So we're going to cut each wave in half in the middle. Well, I can see that the maximum it goes is what? -1, and the lowest it goes is -5. So you could go ahead and average those. You could say, okay, -1 plus -5, then divide that by 2. That'd be -6 divided by 2 is -3. So if I draw a line horizontal through -3, that is the middle, where I have the maximum is the same distance, it's 2 away, and the minimum is 2 away. But I can't just write that number. This is a horizontal line which cuts through the y-axis, so we put y equals -3. Okay, number 2, you can really kind of eyeball it and just see, oh, the middle's right here. Because I'm 1 away from the midline to the minimum, and I'm 1 away from the midline to the maximum. And so that is at y equals 4. And then the other thing we need to talk about is amplitude. An amplitude is a vertical distance from either the midline or from the midline to either the min or max value. So first we have to find the midline again. So we were at bottom is -3 to 1. Split that distance. It should be at -1 is our midline. We want to find the vertical distance from the midline to the maximum or the midline to the minimum. It looks like this is too high. So our amplitude would be 2. It's the vertical height. Okay, and then number 4, we have a taller wave. Let's first find the midline. So we're going from -5 to 1. -5 plus 1 would be -4 divided by 2. It should be at -2. So from this midline up would be 1, 2, 3. Right? I should be 3 units away. So our amplitude is 3.